Greetings, class. This segment is designed to be a brief introduction into a procedure known as linear regression, specifically bivariate linear regression. And for those of you that have made it all the way through Chapter 5 in SPATs, already know or have been exposed to bivariate linear regression. For starters, bivariate linear regression is all about continuing the analysis of a relationship or a potential relationship between two variables. Now, you've already spent some time and effort and homework and exam time dealing with a couple of procedures that also are designed to assess the relationship between two variables, two specifically interval level variables. And those procedures are scatter plots and the calculation of Pearson's R. And those are really the two things that we've talked about so far as they relate to examining a relationship between two variables, Pearson's R and scatter plots. And hopefully, if you've been keeping up with the material, you know how to interpret those two things, scatter plots and Pearson's R, and you know how to generate them, calculate R, and also create a scatter plot if you're given the right enough information. Linear regression, specifically bivariate linear regression. Bivariate means two variables. Bi is two, variate is variables, two variables, bivariate. Bivariate linear regression also involves two variables, which makes sense because we're still talking about relationships. And the best way I can characterize it is that bivariate linear regression builds on both Pearson's R and scatter plots. Bivariate linear regression goes further into defining and describing and modeling the relationship between two interval level variables. And you may not be used to using that word model to model a relationship, but in reality, what we're talking about is modeling. Modeling in this sense simply means describe, in a manner of speaking. Now, if you are a user of Facebook or any type of social media, Twitter, any number of things, those services use models. They use statistical models very similar to what we're about to dive into in our class, linear regression. The models social media uses, however, are designed to help predict, if you will, which news stories you might want to see first, or which friends' stuff you might want to see, material and whatnot. So we can't see models, and actually the technical term that you may have encountered before is algorithm, ALGORITHM, although there are a couple of different ways to spell algorithm. But an algorithm is simply a model. And so we're going to spend the first part of this week dealing with bivariate linear regression models. I have prepared a document that you may have already seen on Blackboard, and it is called "The Quickest and Easiest Regression Guide Ever." Now, I don't know if that is true. That is yours to decide, I suppose. But it is a document. It's actually, to be honest with you, it's not all that quick, but I did try to keep it as simple as possible because linear regression is not an easy thing to explain. And actually, it's probably a little bit more easy. It's easier to do than if you know how to do the math. It's easier to do than it is to explain. But again, bivariate linear regression is all about further exploring the relationship between two variables. So when you get a chance, go ahead and consult the document called "The Quickest and Easiest Regression Guide Ever." And that document will walk you through a number of procedures and other documents, so make sure that you have access to Blackboard when you are going through the Quickest and Easiest Regression Guide Ever. So you can also refer to the other documents directly that the original document, the quickest and easiest regression guide ever, refers to. So so far for this segment at least, when it comes to exploring and defining and describing a relationship between two interval level variables, so far we've worked with two specific procedures: the calculation of Pearson's R, calculation and interpretation of Pearson's R, and the drawing, if you will, the drawing of a scatter plot. In order to round out this portion of the class, we're also going to delve into bivariate linear regression. And by the way, although you'll see it when you get to the document, this top equation here, y equals a plus b times x, y equals a plus b times x, that is the regression equation, and that's something you're probably going to want to become familiar with and probably memorize. Now, if you haven't read Chapter 5, and hopefully that's not true for anybody, but if you haven't read Chapter 5, those two letters, A and B, are probably new to you. Hopefully X and Y are not new. X is simply a value of our independent variable, and Y is a value, in a manner of speaking, a value of our dependent variable. So hopefully those two terms, X and Y, are not new to you. A and B, as you'll see in the document, are collectively known as regression coefficients, but they have specific names. A is referred to as the constant, or it's also known as the y-intercept. It's also known as how much y we're going to have in the absence of x. Check out the document for some more information on that. And B is known as the slope. And the slope, or B, is also known as how much y is going to change for each unit change in x. So y equals a plus b times x. X is our independent variable, y is our dependent variable. A and b together are referred to as regression coefficients. It's those two items, those two numbers, because through calculations you're going to replace those letters with numbers. Those two numbers are going to further describe the relationship between x and y. And here, very quickly, although this is not the only time you will encounter this, so don't worry about that, but here's how you calculate those numbers. And hopefully there's nothing new here. If B is new to you, hopefully there's nothing new here. Pearson's R is simply R. You've worked with R in weeks past. S with a hat sub x, y, or excuse me, sub y, is the standard deviation for your y variable. And again, if you've been working through the Pearson's R exercises, you know what that symbol means. And then S with a hat sub x is the standard deviation for the x variable. So to calculate B, and again, you're going to get this again, but to calculate B, you would take your value for R and multiply it by the dividend of standard deviation y divided by standard deviation x. Then once you have B, as you can see, B plays a role in the calculation of A. Once you have B, then you can, Roxy, our class mascot, is here and she's making noise. Maybe she'll make an appearance soon. I don't know. Roxy, knock it off. A is, again, the constant, and to find the constant, you would take your mean for your y variable and subtract the product of B times the mean of x, right? So you need B in order to find A, and you need R in order to find B, and you need standard deviations and means to find R. So it all works together. If you're getting the sense that it's possible, in fact, some of you have more than a sense, some of you have experienced this directly, making one small mistake in math can have, shall we say, reverberating effects down the line. So anyway, that's an introduction to bivariate linear regression. The next topic is going to be, I'm going to discuss what's known as the line of best fit.